Hello everyone, I'm Aparna from TeachUpX. Welcome you all to the network security training. This network security training is especially designed for students, system administrators, network engineers, or basically anyone who want to take a serious and meaningful step into the world of network security. This is a great starting point for learners who are interested in entry-level networking concepts and skills. In this network security training, you will gain the knowledge and skills to analyze and assess network risk, select and deploy appropriate countermeasures. As part of this course curriculum, you will also be able to understand WPA and WPA2 wireless security models and their vulnerabilities, and also be able to implement the most secure and the popular model in today's wireless landscape. Also, you will learn network security devices, such as we will be discussing about firewall, VPN, IDS, IPS, VPN connectors, and all. Through multiple hands-on exercises, you will learn how to search for possible network security vulnerabilities, how attackers sniff network traffic, how you can implement security configuration parameters on network devices, and also be able to implement wireless security effectively, securely, and efficiently. Alright, in this training, we have different modules that we will discuss one by one. So let's start with Module 1, Network Fundamentals. All students are required to have a solid understanding of TCP/IP and OSI model if they basically want to pursue their career in network security. So this first module covers networking concepts and protocols, network infrastructure basics, and all. Alright, basically the overall objective of this course is to gain the knowledge of the key concepts of computer network, OSI and TCP/IP models, understand different types of network, such as we will discuss local area network, metropolitan area network, wide area network, and personal area network. Then we will be discussing networking components such as an IC, switch, cable, hub, router, etc. Right? Networking protocols, and at last we will be discussing IP addressing concepts. So without wasting our time, let's begin with our first topic, understanding computer networks. So guys, whether you are new into the world of internet or have been working on internet for a long time, or even if you are just a person who likes computers, you use internet regularly. The computer network has revolutionized communications to the extent that it is now our preferred medium of everyday communication. Before digging into the network security and learn networking protocols and services, you must have a knowledge of computer networks. So, here the question arises, what computer network is? A computer network is basically a group of computers, or you can call them nodes or hosts, that are linked to each other, that enables the node to communicate with each other and share their resources, data, and applications. Alright, nodes or hosts can be like personal computers or phones or servers, as well as networking hardware such as routers or switches. So basically, computer network support number of applications and services such as access to the World Wide Web, digital videos, audios, shared use of application, and storage servers, printers and fax machines, also use of email and instant messaging applications, as well as many others. So networking of computers helps the network users to share data files. Right? Now let's discuss the history of computer networks to understand the computer network development. So basically here you can see the number of milestones that they have covered. In 1950s, computer networks included the US military radar system known as SAGE semi-automatic ground environment was started. Then in 1961, the idea of ARPANET, the one of the earliest computer networks, was proposed by Leonard Kleinrock. Also, you can see in the 1960s, the commercial airline reservation system, that is also known as SABRE, went online with 2 connected mainframes. Then in 1963, the concept of intragalactic computer network, basically a computer network that is intended to allow general communications among computer users, was discussed. Also, you can look at 1964, in which researchers have developed the Dartmouth Time-Sharing Center system designed for distributed users of large computer systems. In the same year, a research group supported by General Electric and Bell Labs used a computer to route and manage telephone connections. In 1965, Western Electric, an American electrical engineering and manufacturing company, introduced the first widely used telephone switch that implemented through computer control. Then in 1972, commercial services like X.25 were developed. Then in 1991, home broadband was created. The first home broadband was created in 1991. Then in 1996, the 56,000 modem was invented by Dr. Brent Townshend. In 2000, Cisco achieved a stock market capitalization of more than $550 million. That basically made Cisco the single most valuable corporation in the world. In 2001, home broadband enters mainstream usage and begins growing at a faster rate than internet dial-up services. In 2010, you can see 100 gigabit Ethernet standard fully completed in 2010, and in 2020, the ultimate goal of terabit optical Ethernet center enabling 100 terabit Ethernet by 2020. So this is how you can see the computer network is changing the world of communication. All right. So this is here we have discussed about computer networks and the history of computer networks. Now the next important part that we are going to discuss is networking topologies. So basically networking topologies is also important to understand how you are connected in your network, how basically you are connected with the internet, how you are using, or if you are the particular system in your network, or you are using multiple number of devices in your network, so how these devices are connected, right? Or you can choose which topology to connect in that particular network. So this is here we are discussing networking topologies. First we are discussing bus. So bus topology, we have number of topologies like bus, star, ring, mesh, hybrid, tree. These are all the topologies that you can choose to connect or to basically discover the complete networking architecture of your network, of your organization basically, right? So first we are discussing bus topology. So bus topology is a type of network where every device is connected to a single cable which runs from one end of the network to the other. Bus topologies are basically used in smaller networks because all devices are connected to a single cable, so you don't need to manage a complex topological setup, right? It's cost effective because you know that they can be run with a single cable. You don't need to purchase number of devices, or you don't need to purchase number of cables, so it's very cost effective. But the drawback of this topology is that if the cable fails, then the entire network will go down. Also, if you have lots of network traffic, then the performance of your network will decrease significantly. All right, so this is bus topology. Next, we are discussing star topology. So star is basically, you can see that structure of the star, right? In this star topology, every node in the network is connected to one central node. All right, the central node or hub also acts as a repeater. You can manage the entire network from one location because you are just connected with the central hub, so you can manage all the resources from that central hub. If the central node goes down, then the entire network will go down, obviously, right? So this is the drawback of star topology, because if the node gets down, or if there is any disconnectivity in the node, then whole architecture will go down. Then next we have ring topology. So you can see a complete ring architecture here. Here computers are connected to each other in a circular format. Ring topologies can sustain large networks much more effectively than bus topologies. All right. Then we have dual ring topology. You can see we are using here double cables simply, right? In ring topology, we are using a single cable, or you can say one-way communication, or you can say it can be clockwise or anti-clockwise. But in dual ring topology, we are using dual cables. That's why it's called dual ring. And the communication in dual ring topology can be clockwise or anti-clockwise. So basically, if ring topologies are configured to be bidirectional, then they are referred to as dual ring topology. Data can flow in a clockwise or counterclockwise direction. Dual ring topologies provide you with an extra layer of protection as they are more resistant to failures. All right. Then we have next topologies that we are discussing is tree, mesh, and hybrid. So in tree topology, you can say it's a network structure that is shaped like a tree with its many branches. The most significant weakness of tree topology is the root node. So if the root node fails, then all of its subtrees become partitioned. Right? You can just separate them and create a next tree, you can say. All right. Then we have mesh topology. So as you can see, it's a complete mesh. A mesh topology is a point-to-point connection where nodes are interconnected. The topological layout is more complex because you can see here in the diagram that one system is connected with number of systems, so it can be the complex architecture, right? Also, you can see here you can use basically full mesh or partial mesh topology. In partial mesh topology, you can basically connect to a number of devices that you want, or in basically full mesh topology, you have to connect all of the devices with other number of devices. So it can be partial mesh and full mesh. Then we have hybrid topology. So when a topology is comprised of two or more different topologies, it is referred to as a hybrid topology, right? Like in this architecture, you can see we are using one ring topology and other one is star topology. This is the ring topology and this is we have star topology. So basically, if you are combining one or two or more topologies, then it's called hybrid topology. But hybrid topologies can be quite complex depending on the topologies that you have decided to use. All right, so here we have discussed computer networks, the history and networking topologies. Right, thanks you. In the next video, we will be discussing about the communication channels like OSI models and TCP/IP models. All right, thanks.